In lesson 94, we're looking at dependent and independent variables, functions, and functional notation. So let's look over here. I have a few rules typed out. An independent variable is the variable with the assigned value, usually the x is how we'll see that. And the dependent variable is the variable that depends on the independent variable's assigned value, usually the y. Okay, for a relation to be a function, okay, now the domain, which is the x values, must be specified or implied. Number 2, a way must be designated to find every image or answer for every x value. You must be able to find the corresponding y value. Number 3, their number must be exactly one image for every member of the domain. So every x value should have only one y value, but you couldn't have, or you could have the same y value for all x values and it would still be a function, but you can't have one x value that gives you more than one y for it to be a function. Alright, so looking at these examples over here, we're going to see which ones depict functions. Okay, so on A, 4 gives me 3, and 3 also gives me 3, and that is a function because each of these x values are only going to give me one y value. It's okay that they're giving me the same one. Then on B, 7 gives me 3, and 5 gives me 4, and 3. So that is not a function. So this would be a function. And this is not a function. Because the 5, the x value of the 5, is giving me 2 answers instead of just 1. Okay, on C, I have 4 that gives me 5, 6 that gives me 7, and M, it shows gives me nothing. So this is not a function because I have a value in x that doesn't give me an answer. Okay, and then on D, we have the real numbers. Any real number put in for x is what this means to get the y value that would go in here. So I put in any of the real numbers for x, add 2 to that number, and then I get the y value that would go in this box over here. So that is actually a function. Okay. So then we're given these ordered pairs and we're going to find if they are functions or not. So first I'm looking at my x's. I have a 4, a 7, a -3, and a -6. So all the x's are different. And then I have a 3, 5, -2, and -4 for the y's. And all the y's are different. So according to what they've given us, it would be a function. Because none of the x's repeat. So they're not giving us more than one value for each x. Then on B, we have 4, 3, 5, -2, 7, 3, and 6, 3. So we see that the y's are repeated, but that's okay. The x, each x only giving us one answer, so from what they've given us, that would also be a function. Alright. Then on C, we have 5, -2, 4, -3, 7, -2, and then a 5, 4. Now because I have the same x giving me 2 different answers, that would not be a function. Okay, and on D I have 7, -2, 3, -2, 6, 5, 4, 5. So none of my x's are repeated, and they all are only giving me one y value. Even though some of the y values are repeated, it would still be considered a function. Now, if they repeated the same x value with the same y value, it would still be a function. But because these y values were different, it was not a function. All right, now into functional notation. So if we're given two functions and we need to distinguish between them, we can use functional notation. So I'm basically replacing the y with an f of x or a g of x. You might use h of x, p of x, k of x. They could use different variables with an x in parentheses, and that's basically just taking the place of the y so that we can distinguish before different functions that are given to us. So here they replace the y with an f of x. And then if they want you to evaluate that function at 2, they would have f of 2, and then they would replace the x with the 2 here also, and then you would just be looking for this answer. You'd go ahead and say 6 plus 2 is 8, so f of 2 equals 8. Okay, and you wouldn't try to divide by the 2, just leave it as the 8. Okay, and the other function that we're given, they replace the y with g of x, and then they want us to evaluate when x is 3. So it says g of 3 equals 4 times 3 minus 5. So that would be 12 minus 5, which is 7. So g of 3 equals 7, and you just leave it like that. Okay, then we have an example here. It says if h of x equals 4x minus 3 and p of x equals x squared minus 3x, find p of negative 3. So really, we didn't even need this other function. We're going to put the negative 3 in for this x here, and here, because it's p. So we have p of negative 3 equals negative 3 squared minus 3 times negative 3. So we'll have 9, and then that would be a negative times a negative, so plus 9, so it would equal 18, and just leave that as p of negative 3 equals 18, and then you're done. If you have any questions, feel free to ask me, email me, however you need to contact me, and I'll try to answer them to the best of my ability.